This video is about the number sets and how to identify and describe the relationships. So there's four types of number sets that we're going to talk about for the purpose of this class. We have natural numbers, we have whole numbers, we have integers, and we have rational numbers. So let's learn a little bit more about each set of numbers. What was the first set of numbers we learned about as kids? So thinking back to when we first started learning about numbers, we learned how to count with our numbers. So we use the natural numbers in order to count. So the first set of numbers that we learned were the natural numbers. Examples of natural numbers then are 1, 2, 3. We can keep going and going and going. 105, 1073, and we can keep going and going and going. Any number that you can theoretically count to is part of our natural numbers. How are the whole numbers different from the natural numbers? So the next group of number that you learned about were the whole numbers. The only difference between the whole number and the natural number is that they added a 0 into that set of numbers. So the whole numbers include natural numbers and 0. So that's the big difference. Whole numbers also include 0. So examples would then be 0 and then anything else that we've already had in our number sets. What are integers? So the next group of numbers that we started to learn about were integers. Integers also include negative numbers. So integers are the whole numbers and their additive inverse, which is the negative. It's called an additive inverse because it's the number we can add to the positive to get 0. So for example, 5, the additive inverse would be -5 because 5 plus -5 gets us 0. So examples then, we could have any negative number like -3, -2, -1, 0, 1, 2, 3. We go forever in both directions. The last set of numbers then are our rational numbers. Rational numbers are anything that can be expressed as a fraction. This is going to include every number we've already talked about, as well as decimals, because all of these can be expressed as a fraction. So rational numbers are any number that can be expressed as a fraction. It includes our positive and negatives as well. So we could have something like -7/3, something like -2.17, -3, 0, 6, 9.7, 1/4. Those are all examples of rational numbers because they can be rewritten as a fraction. So even a whole number like 6, remember, it can be written as a fraction because we could put it as 6/1. So let's use the idea of these numbers to fill in our chart below. Now, when we fill in this chart, we're going to start with the smallest group of numbers, and as our circle gets bigger, we're adding more and more into them. So the first smallest circle is going to be our natural numbers. Remember, that's the first group that you learn to count with. So 1, 2, 3. The next group then includes one extra number, which is 0. So this circle is going to be our whole number. This includes 0 and includes 1, 2, 3. Remember, things from the past group also are included, and then we add to that group. The third group is the integers. So this includes our negatives and our positives. And then the last group that we have is our rational numbers. Remember, the rational numbers is going to be our most inclusive group. It's going to include the most different types of things. So remember, natural numbers can include negative fractions, negative decimals, 0, negative numbers, positive fractions, and positive decimals. So given the numbers, we're going to identify what type of class number they are in. Remember that some of them can be in multiple classes. So if it's a natural number, it could be in all groups, because if we think about our chart, the natural number circle is actually in all of these circles. So number 5, our number is 11. 11 is a natural number. It's a number I can count to. So because it's a natural number, it's also considered a whole number, an integer, and a rational number. Number 6, 2/3. 2/3 is a fraction, which is a rational number because all rational numbers are expressed as fractions. 7, -3. -3 is a negative number. Integers is when we start including our negatives, which also means it's a rational number. 8 is 0. We start including 0 as a whole number, an integer, and a rational number then. Number 9, 0.45. Remember, 0.45 could be converted to a fraction, which means it's part of our integers. -14 is a negative number, so it's an integer and a rational number. Number 11, 1,483. It would take me a long time, but I could count all the way up to that number, so it's considered a natural number, a whole number, an integer, and a rational number. And then our last one, -0.33, is a decimal, which could be expressed as a fraction, so it is a rational number. The last problems that we're going to look at are some kind of explanation problems where we figure out how number sets relate to each other. So number 13, given the set of rational numbers and whole numbers, which number set is contained within the other and why? So we have to think about which number set is bigger and contains more than the other number set. So number 13, when we're giving rational numbers and whole numbers, rational numbers are going to contain the whole numbers because they include your whole numbers, but rational numbers, remember, also include our fractions. That's the big component that changes with rational numbers. So we're going to say rational numbers contain whole numbers, and then we need to explain why. Because rational numbers include whole numbers, and this and is important because we need to say what else do they include? Why are they the bigger group? So we're going to say and any number that can be expressed as a fraction. Let's look at one more example. So given the set of integers and natural numbers, which number set is contained within the other and why? So in this case, which number set is bigger? This time it's going to be the integers because they also include negative numbers, while natural numbers only have positives. So we're going to say integers contain the natural numbers because integers include natural numbers and their negatives, or as we call them, additive inverses. If you want to just call them negatives, that's fine too.